Welcome back to next lecture. Today we will discuss some important applications of functions in economics. See, from the definition of function, we understood that the function describes the relation between two or more than two variables. See, the nature of this relationship between the variable is generally indicated by using formula or graphs or mathematical equations. And each of these representation provides a way to understand and analyze the connections between the variables. See, as we said that the function involve one or more variables. These variables represents the quantities or characteristics that can vary. It shows that the change in one variable in relation to change in another variable. See, for example, y is equal to 10x cube. See here, the x and y are the variables, and we know y is the symbol that represents unspecified number or value. And it can assume any value and expression. It is entirely depending upon what value you are going to assign for x. See here the number 10, which is the coefficient of the variable x. And the coefficient is a numerical factor that actually multiply the variables. So in this case, 10 work together with x. Along with x, see, there is an exponent here is 3, representing x raised to the power 3, indicating that x is multiplied itself thrice. And you know the y is the dependent variable and x is the independent variable. And so function is a mathematical relationship in which the value of single dependent variable are determined by the value of one or more independent variables. A function tries to define these type of relationships. See, economists always tries to modeling the relationship between various economic variables. And economic function, it describes how one economic variable depending upon one or more other variables. In economics, we often deals with various theories, models, hypotheses, which tells the relationship between different economic variables. For the better understanding of this relationship, we use different types of functions such as demand function, supply function, utility function, production function, cost function, consumption function, saving function, etc. And here we are going to discuss such a types of functions in detail. See, the first such a function is demand function, which is one of the most popular concept in economics. See, it represents the relationship between the quantity demanded of a goods or services and various factors which are influencing or various factors which are affecting that particular quantity demanded. And the demand function that specify the amount of particular commodity that a consumer or buyer are willing and able to purchase at each prices in the series of possible prices during a specific period of time. And we know that there are many factors that affect the quantity demanded of a particular commodity, such as the most important factor, that is price of commodity, income of the consumer, price of related commodities, taste and preferences of the consumer, then expectation about the future, climate change, government policies, etc. Therefore, we can represent this relationship between the demand and its various factors. That is, these factors are written in a mathematical format. That is, quantity demanded is a function of price of commodity, income of the consumer, price of other commodities, then taste and preferences of consumer, etc. So, but we are keeping those factors constant to describe a clear relationship between the demand and price. The price is one of the most important factor which determine the demand for a commodity. So normally we can see a negative relationship between the demand and price. As you know, when the prices increases, demand goes down, and when prices decreases, demand will goes up. Therefore, by simplifying, we can write the demand function, that is quantity demanded is equal to the function of price. Usually these functions are curves rather than a straight line, but straight line provide a good illustration of the demand characteristics. So here on the x-axis we are taking the commodity X, and here we are taking the prices of the commodity, and there exists a inverse relationship between price and quantity demanded. That's why the demand curve is downward sloping. Now see the simple example of a linear demand function. See, the quantity demanded is equal to A minus BP, where QD is nothing but it is a quantity demanded, P is the prices of the commodity, and A is the intercept of the demand curve. That means the quantity demanded when price is 0. And what about B? B is the slope of demand curve, which means it is the rate at which the quantity demanded change when the price is going to change. See the negative sign in front of B, this minus B. It is a negative sign which signifies, there exists a inverse relationship between price and quantity demanded as per the law of demand. For example, the quantity demanded is equal to 100 minus 2P. See, in this example, the coefficient A is the 100, which is the intercept term, and B is minus 2, which represent, it is the slope, and it suggests that for every 1 unit increasing in the price, the quantity demanded decreases by 2 units. Okay, this is all about the demand function. Now consider another type of function which is known as supply function. It is also a much popular term in economics, which specifies the amount of a particular product that a producer is willing and able to produce and make available for sale at each price in a series of possible prices during a specific period of time. So like the demand function, the supply also affect the number of factors and the circumstances which can influence the producer's willingness and supply of the commodity in the market, like prices of the commodity, price of factors of production, price of related commodities, the technology which we are going to use, goal of the producer, government policy, and such a miscellaneous factors. We can include the factors such as, means of transportation and communication, natural factors, taxation policy, expectation, agreement among the various producers, etc. So accordingly, we can write the quantity supplied is a QS, which is denoting for the quantity supplied, which is equal to the function of price, price of factors of production, price of other commodity, technology, then it is goal of the producer, government policy, etc. So here we are keeping all the factors other than demand as a constant. The quantity supplied is a positive function of price, in which when the price increases, the quantity supply is also increases, and when the price is decreases, the quantity supply is also decreases. So there exists, positive relationship between the price and quantity supplied of a commodity, which we can mathematically denote a functional form, that is quantity supplied is the function of price, where function P is the one of the most important factor which determine the supply of goods and services in the market. Now let us consider one example, that is QS is equal to 10 plus 3P. This is a linear supply function which implies that for every 1 unit increasing in the price, the quantity supplied will also increase, because we are using it is plus 3P. So here this sign is used by positive sign. So for every increase in 1 unit price, there is a 3 unit increasing in the quantity supplied. So this is all about the supply function. Now another function is, see, it is the cost function. The cost function in economics, it represents the relationship between the cost of producing certain quantity of goods and services and what are the various factors which are actually affecting the cost of commodity. So the cost function, it is a crucial for, business people, those people who are working in the business activities to efficiently analyze and manage their production processes. So it expresses the relationship between the cost and its determinants such as, the level of output, the plant size, input price, technology and managerial efficiency, etc. So mathematically we can express it is the cost is equal to function of output, the plant size, then price of inputs, technology, managerial efficiency, etc. So here C is the unit cost, that means it is the total cost and it studies the behavior of the cost at the different levels of output. When other things like the technology, cost of production, etc. are assuming constant, we can say that cost is the function of output. The cost is the function, the total cost is equal to the function of Q, where Q is nothing but it is the quantity of output which producer is going to produce in the market. So it shows that there is a direct relationship between cost and output. That means higher output of the firm, higher will be the cost of production. And thus the cost function refers to the functional relationship between cost and output. And see, the total cost of producing goods can be analyzed into two parts. One is fixed cost and another one is variable cost. Fixed cost, which is the independent of output which you are going to produce, and variable cost is varying along with change in output. We are going to show a simple, linear total cost function which will be look like this. See, the total cost is equal to 50Q plus 1000. See, in this example, this 50Q represent is variable cost component. This is a variable cost component, and 1000 represent it is a fixed cost of component, because even if you are going to produce zero output, that means if Q is equal to 0, then also your fixed cost is remain constant, that is 1000. So which represent the fixed component. So the total cost increases with change in the quantity, reflecting that variable cost element, especially the 50Q. If 50Q is going to change, then your total cost is also going to change. And the fixed component, that is 1000, remain constant regardless whatever the amount of goods and services which you are going to produce. Okay. So that's all about the cost function. Now along with the cost function, we have a total revenue function. See, it is total revenue function, which is the total income a firm receives from selling a specific quantity of goods and services. And it is calculated by, it is multiplying how much quantity you are going to sold in the market and by price per unit. So it is equal to the total revenue is equal to price into quantity. It is price into quantity. So the total revenue function is a mathematical representation that how the total revenue change in response to the change in the quantity sold or the price per unit. So it is expressed as a function of quantity or price, and its form is entirely depending upon the specific condition, that is the total revenue is a function of the output and the price. So it is the total revenue as a function of quantity and the price which is sold in the market. So understanding the total revenue, total revenue function, it is essential for especially the business people to analyze how changes in the price and quantity affect their overall revenue or their overall revenue performance. So this is the total revenue function. Now we have another function which is known as profit function. See, profit function represents the relationship between the firm's profit and the quantity of goods and services it produces and sells in the market. So profit function is calculated actually the difference between the total revenue and the total cost. So if the total revenue is, for example, if the TR is the total revenue and TC is the total cost, then the profit function can be generally written as C pi is equal to, that is profit is equal to total revenue minus total cost. So the profit function provide a insight into how changes in the production level impact the firm's profitability. So it is a fundamental tool for the business to make a decision about the production quantities, pricing strategies and the overall performance of a company. Now for example, see here the total revenue is equal to 10Q minus 0.5 Q square and the total cost is equal to 5Q plus 2Q square. And what will be the total profit function? We know the total profit function is equal to the total revenue minus total cost. So it will be total revenue which is 10Q minus 0.5Q square minus the total cost, that is within the bracket we are writing it is 5Q plus 2Q square. If you go for opening the bracket, then it will be 10Q minus 0.5Q square minus 5Q minus 2Q square. So this is the profit function. Now consider the production function. See, a production function expresses the relationship between the quantity of input which is used in the production process, how much quantity of input which is used in the production process and the resulting quantity of output. So actually it explains how the input, for example labor, capital are actually transformed into goods and services. So for example, if Q is the amount of output which is produced by a particular firm by using labor and capital, land, organization which are generally employed, because we have a 4 factors of production which is generally used for the production process. So in the production function we can written as CQ is equal to function of labor, capital, land and organization. We have a 4 factors of production. So although the production function is depending upon all these 4 factors of production, we can say that there are 2 most important factors which are used for the production, which is generally known as it is labor and capital. So that's why the general form of the production function is often written to as CQ is equal to function of labor and capital, where Q is the level of quantity of output which is produced in the economy and L is the quantity of labor input and K is the quantity of the capital input. So the production function may take different functional forms which may depending upon on the nature of production process. There are many types of production functions, like we have a linear production function, we have a Cobb-Douglas production function. For example, the linear production function will be look like, see, Q is equal to AL plus BK, where A and B are the constant representing the marginal product of labor and capital respectively. Similarly, we have another production function, we can say that it is a Cobb-Douglas production function, which is one of the widely used production function which is known as Cobb-Douglas production function, and which can be generally written as CQ is equal to A into L raised to the power alpha K raised to the power beta, where A is the positive coefficient constant and alpha and beta are the constant representing the output elasticity of labor and capital respectively. So this is all about the production function. Now we have another type of function which is generally known as it is the utility function. See, the utility function which shows the individual preferences or the satisfaction from consuming goods and services. So the utility function is denoted generally by using capital letter U and is typically expressed as a function of quantity of various goods and services which is consumed by a particular consumer. For example, see, if we have 2 commodities, commodity X and Y, which are the 2 commodities where consumer is purchased for the consumption, then the utility which is derived from this commodity can be written as, see, utility is a function of 2 output or 2 commodities, that is commodity X and commodity Y. So utility is a function of X and Y. Consider another simple utility function which is also a function of two commodities, that is x and y, which is equal to x raised to the power 0.5, y raised to the power 0.5. And in this example, see, the utility is derived from the consumption of commodity x and commodity y is proportional to the square root of quantities of each commodities. So in general we can say that a utility function, which is nothing but which shows the satisfaction from consumption of how much utility a particular consumer is actually getting from the consumption of goods and services. So this is utility function. Now we have another function which is known as consumption function. See, the consumption function represents the relationship between income and consumption, and it is typically denoted as C is equal to it is C0 plus BY, where C is our total consumption, or it is a consumption function, and C0 is the autonomous consumption, and which means that it is the level of consumption that occur even when your income is 0. For example, if your y is equal to 0, income is 0, then by term will become 0, then also your C0, that is autonomous consumption, will be remainder. So it is the minimum level of consumption that individual and household required regardless of their income. At the same time, here the coefficient B, which is generally known as, it is marginal propensity to consume, or it is MPC. It represents the fraction of additional income that individual or household will allocate to consumption. In other words, we can say that it is the responsiveness of consumption to change in income. That means how much proportion of your increased income will be utilized for the consumption purpose. So Y is the level of income and that B is the marginal propensity to consume. Now see, the consumption function, we express it is the depending upon the level of income, and of course the income is the most important factor. And according to the equation, consumption comprises of autonomous consumption and consumption that depending upon the level of income, that is BY, which represents additional consumption resulting from changing in the level of income. So as your income increases, the individual tends to spend a portion of increased income on additional consumption, and this is actually B represent, that is proportion, this proportion of that increase. So of course we can see a particular consumption function which is given as, see here C0 is equal to autonomous function, B is the marginal propensity to consume, and Y is the level of income. Now let us consider a particular consumption function which is equal to 50 plus 0.8y. It implies that a autonomous consumption of 50, that means even if your level of income is 0, your consumption will be 50 units. And 0.8, which is nothing but it is marginal propensity to consume, and Y is the level of income. So this is the consumption function. Now along with the consumption function, we have another function which is known as saving function, which is also similar to the consumption function. See, we have the saving function and it mainly represents the relationship between income and savings, that is income and saving. So but we know the Y is equal to C plus S, which means your income is equal to, which is used for the two purpose, which is the consumption purpose and for the saving purpose. That's why we are writing Y is equal to C plus S. Either you will use your income for the consumption purpose or for the saving purpose. So we can isolate the saving function, or we can derive the saving function from here by isolating S. See, we can write it is Y minus C. The saving function is equal to Y minus C, where S is the level of saving and Y is the disposable income and C is the consumption level. So here also showing that as your income or disposable income increases, your saving is also increases. And that's why we are saying that saving is also a function of income. If your income is going to increase, then saving is also going to increase. Similar to the consumption function, the consumption function also, we said that consumption is a function of income. As your disposable income increase, the consumption is also going to increase. Now, suppose we have a saving function given as, see here, the s is equal to 0.2y minus 30. 0.2y minus 30. See, in this equation, see, s is the level of saving and y is representing your disposable income, and the saving function which actually implies the portion of your disposable income which is to be saved. And you know, this particular point 2, marginal propensity to save, that is how much proportion of your increased income is used for the saving purpose. So here it is showing that that particular proportion is equal to 0.2. So it is 0.2y. So which means that if individual choose to save the 20% of their every additional increasing in the disposable income. So if your income is increasing, then 20% of your increased income is used for the consumption purpose for additional increasing in the disposable income. So the constant term, that is minus 30, this is saving function, that is it is negative 30, which implies that it is actually dis-saving. It is dis-saving, that is irrespective of your disposable income. Okay. So dis-saving, which actually means that the individual are spending more than their disposable income. That is, savings fall below zero when your disposable income is zero. So this is all about the saving function. Let me conclude here. In this lecture, you know, we discussed some of the applications of function in economics. See, besides these types of applications in economics, we have many more functions in which, you know, in which we will discuss due course of time. And in the next lecture, see, we will discuss the graph and the drawing of a linear function, then how to find the slope, especially from, you know, if the coordinate points are given. All these things will be discussed in the next lecture. So we will see in the next lecture. Thank you.